I'm mathematics and physics tutor. I touch IGCSE A level up to university. For physics, I teach up to A level only. So this is physics paper, and you can reach me through this number. You can WhatsApp that number or you can call it, but the most preferred way is to WhatsApp it, or you can email me through the address I'm going to attach in this video. So the question one, normally this paper, we are normally given a formula and not a formula but the concept you'll be using, and for formulas as well, So which unit is an SI base unit? This is a question. Of course, we know very well that our answer is ampere. So when you look at Coulomb, that's electric current, right? Degrees Celsius, that's temperature. When we talk about grams, that's for mass. So mass is quantity of matter in an object. Its SI unit is kilogram, okay? But other units of mass is grams. We also have milligrams. We also have tons. So when we talk about tons, we talk about huge objects like vehicles. We talk about huge machineries. When we talk about kilogram, we talk about moderate quantities like humans. We can talk about animals like cows, sheep, etc. There are some things you can measure in grams. They are a little bit less quantifiable as compared to what we are discussing. Then we have the milligrams as well. So for example, when you want to measure the mass of spoonful of salt, we measure in grams, okay? Degrees Celsius, this is for the temperature. We can also measure temperature in Kelvin. In fact, that is the standard international unit of temperature. Question 2, which of the following could have the same units as force? How do we define force? A force of a particular object is its mass, the product of its mass and the gravitational pull of that particular place. So if it is, let's say we are on Earth, the gravitational pull of the Earth is normally approximately 10 Newton per kilogram. But let's see what we've been given here. We've been told that we should use the acceleration of free fall to be 9.81, meaning that we will use gravitational pull to be 9.81 meters per square second. Okay, let's go back to the question. Energy, distance, they are saying energy all over distance. Then we have energy all over time. So when you are measuring a force, what do you identify? Which particular parameters do you look at? What we know, we look at the energy, that's correct. When we talk about pressure, we normally say it's a force acting perpendicularly, normally per unit area. When we talk about force itself, we normally measure mass, then we multiply by the gravitational pull. So the answer is part A. When we talk about energy all over time, per unit time, no, a force cannot be measured per unit time. It's measured per unit distance. Momentum. What is momentum? Momentum is the product of mass. The product of mass and the distance. When you talk about momentum times time, so in physics we use a formula to define a term. Momentum is mv, not distance, mv. Momentum is calculated by taking mass times velocity. That's why we say momentum is the product of mass and its velocity. And its velocity. For more information, contact me.